In the last video, we figured out the absolute minimum speed in order to stay on the circular path right over here, especially near the top, was 27.6 kilometers per hour. What I want to do in this video is I just clipped out the parts where he's actually on the loop-de-loop, and I want to actually figure out his average velocity. So I'm going to use the video editor right here to time how long it takes to complete the loop-de-loop, and then we can use that and what we know about the circumference of this loop-de-loop, and we're going to assume that it is perfectly circular for our assumptions, although it looks like it's a little bit egg-shaped in reality or a little bit elliptical. But for our calculations, we're going to assume that it is perfectly circular, and I'll leave it to you to think about how it would change if you had an elliptical shape like this. So with that out of the way, let's watch the video again. Remember, this is from Fifth Gear, which shows on the Channel 5 in the United Kingdom. So there you go. Let's watch it again. That's just fun to watch. There you go. And right over here, we have the little timer for my video editor. And this right over here is in seconds, and I was corrected on an earlier video. This right over here is not in hundredths of seconds. This is in frames, and there's 30 frames per second. So it starts at 0 seconds, 0 frames, and then when we play it, it goes to 2 seconds and 14 frames. But that's 30 frames per second. So it's 2 and 14/30ths of a second is how long it takes this car to do the loop. So that's 1 second and then 2 seconds. 2 and 14/30ths. So almost 2.5 seconds. So let's write that down. So the time, and this is all rough because I'm approximating right over here, the time required to do the loop-de-loop is 2 and 14/30th, 14/30 seconds. And what is the distance that it traveled? If we assume that this thing is circular, although it looks like it's a little bit more egg-shaped. If we assume that it's circular, then the distance traveled is the circumference of the circular loop-de-loop. The circumference is 2 pi times the radius, which is equal to 2 pi. And in the previous video, we figured out that the radius was 6 meters. So it's 2 pi times 6 meters, which is equal to 12 pi meters. So if you want to figure out its average speed, I should say, the velocity is constantly changing because the direction is changing. But the magnitude of the velocity, if we want to figure out the average magnitude of the velocity or the average speed, we would just have to divide. So let me write it over here. Average speed, the total distance traveled is 12 pi meters, divided by the time required to travel the 12 pi meters. So that is 2 and 14/30 seconds. Now let's get our calculator out to actually calculate that value. So we're going to have, the distance is, let me clear this. So we have 12 pi meters divided by, let's write this as 2 plus 14 divided by 30, just to get the exact value. 2 plus 14 divided by 30. And then this gives us in meters per second, 15.3 meters per second. So the average speed is approximately 15.3 meters per second, which is almost twice as fast as we figured out that minimum speed it had to be. And that's because you want that margin of safety, and you want to be able to have some traction with the road. Although you don't want to go too fast, because then the G-forces are going to be too big. Then this, and maybe we'll talk about that in a future video. But just to relate this into kilometers per hour, let's figure out what that is. Whoops, that's not what I wanted to use. I wanted to use this one right over here. So that's in meters per second. Let's figure out how many meters per hour by multiplying by 3,600 seconds per hour. So that's how many meters per hour divided by 1,000, which you can kind of see right over there. That is 55 kilometers per hour. And if you wanted to do it in miles, a rough approximation divided by 1.6, it's about 35 miles per hour, give or take, or 55 kilometers per hour. So this is approximately 55 kilometers per hour. So the driver here, luckily they did the physics problem ahead of time, and he had the margin of safety. He was well in excess of the minimum velocity just to maintain the circular motion. So he probably had some nice traction with the track up here.